Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Afifah binti Abdul Jalil, and this is my teammate Nur Atika binti Kasim, and the other one is Nur Dini Atira binti Kamal Arifin. Our title final year project is modeling the distribution of rainfall amount, and our SV is Madam Isniwati binti Abdul Malik. We go the first part, which is introduction. Rain is a combination of many droplets of water that fall from clouds. The water droplet in the cloud combine together to become bigger drop. The intensity of rainfall is a measure of the amount of rain that occurs over time. Rain gauge is used to measure rainfall. Malaysia currently uses a tipping bucket rain gauge (TBRG) in modern automatic weather station. Rain is very helpful in balancing the temperature on the earth. Rain offers a renewable resource that can fulfill the food production needs. If the water is not managed properly, a natural disaster can occur. Flood situation also causes many waterborne diseases, which ultimately causes the death of many people. Malaysia is an Asian state which located in the north of the equator. In tropical weather, there are only two seasons, which are dry season and wet season. For the northeast, which are Perlis, Kedah, Penang and Perak, is experiencing the wettest season from November to March. While southwest, which are Johor, Melaka and Negeri Sembilan, is experiencing monsoon season from May to September. This figure shows a line graph of average precipitation millimeter per day in Negeri Sembilan. Negeri Sembilan consists of 7 districts, which are Seremban, Kuala Pilah, Rembau, Jelebu, Tampin, Jempol and Port Dickson. As we can see, the highest amount of rainfall is in November with an average 11.7 mm, while the second highest is in December with 7.5 mm per day. Moreover, February experiencing the lowest average precipitation millimeter per day, while the second lowest average precipitation is in July. Problem statement. Rainfall is crucial for water resources management, economic growth, and agriculture activities. The occurrence of dry period or heavy rain may lead to the natural disaster. Hence, the government need to invest a huge cost in order to solve this problem. Preparation to overcome this disaster can be made by studying earlier the characteristic of rainfall. So, this study concentrating in the best fitting distribution of rainfall amount in Negeri Sembilan. The objective for this study is to determine the characteristic of rainfall in Negeri Sembilan, to estimate the best parameter for amount of rainfall using maximum likelihood estimation, and to identify the best fitting distribution of rainfall in Negeri Sembilan. For research question, firstly, what is the characteristic of rainfall amount in Negeri Sembilan? What are the best parameter estimate to construct the distribution of the model? Lastly, what is the best fitting distribution of rainfall in Negeri Sembilan? For scope and limitation, this study had covered the area in Negeri Sembilan. Therefore, the result found in this study was only applicable in Negeri Sembilan and cannot be extended to other states. Furthermore, the study was conducted in less than 1 year. Hence, the time constraint was contribute toward the limitation of the study. Data obtained were general form and were needed to be understood. Lastly, this study required high expenses because the data needed to were stored at the Department of Irrigation and Drainage at Ampang.
Hi, my name is Nur Atika binti Kasim and I will proceed with the methodology. In this study, we use a secondary data. The data are obtained from Malaysia Drainage and Irrigation Department at Ampang. There are 7 stations that are interested to be in this study. Each station represents every district in Negeri Sembilan. The Nina Tideda software are being used to collect the rainfall data. Okay, proceed with the description of the data. The variable name is rainfall amount. The type of variable is quantitative continuous. The scale of measurement is ratio. The description of the data is the amount of rainfall by each station in millimeter. The software that are being used for the analysis of the data are eView software and RStudio software. In modeling the rainfall amount, the distribution that are being chosen are normal distribution, gamma distribution, Weibull distribution, and exponential distribution. In maximum likelihood estimation, the shape, scale, and rate, or known as alpha, theta, and gamma, are estimated using MLE method. Firstly, we need to calculate the likelihood function using this formula. However, in calculus, it is used to find the value of theta that maximizes the likelihood function L. The parameters are obtained by differentiating the log likelihood function with respect to the parameter of the distribution. And lastly, to continue the process of maximization, set the derivative of L equal to 0 to solve the theta. In model selection criteria, we evaluate the value of Akaike Information Criterion (AIC) and Bayesian Information Criterion (BIC). The values are being compared and written a smaller value and preferred as the adequate fit to the data. For the goodness of fit test, the Anderson-Darling test will be used. This test is used to test a sample from a population with a specific distribution in calculating the critical value. This test also allowing a more sensitive test. The critical value will be calculated for each distribution. This is the summary of methodology. To fulfill the first objective, which is to determine the characteristic of the rainfall, we will use a descriptive statistic, such as a frequency, mean, median, and line graph. Next, we will use a maximum likelihood estimation to estimate the best parameter of the 4 distribution. And for the last objective, which is to identify the best fitting distribution of rainfall in Negeri Sembilan, we will use the Anderson-Darling goodness of fit test, AIC and BIC.
Result and findings. This chapter presents the result of analysis based on research objective, which are descriptive statistics for all selected stations, the best parameter using the maximum likelihood estimation, goodness of fit test, and the best fitting distribution using the model selection criterion. This table shows the summary of descriptive statistics for all stations in Negeri Sembilan. The period of data collection is taken from year 2010 to 2019. In this station was selected based on the availability of the data and the least missing value problem. The result shows that Lorong Perhentian Tinggi has the highest value of maximum monthly rainfall amount with 604 mm per month. The lowest value of maximum rainfall amount belongs to Sungai Kepis with 379.5 mm per month. The overall statistic shows the rainfall variability is homogeneous due to the range of means and variance. This figure shows the line graph of the total amount of rainfall in Negeri Sembilan annually from year 2010 to 2019. It consists of 7 districts, which are Seremban, Kuala Pilah, Rembau, Jelebu, Jempol, Tampin, and Port Dickson. The result shows that the highest total amount of rainfall is in 2019, with the total amount of rainfall 45,278.51 mm. The lowest total amount of precipitation, which is 12,795.5 mm, belongs to year 2015. Furthermore, this line graph shows the characteristic amount of rainfall against month. Negeri Sembilan received most of its rain from October to November. From May until September, it experienced a gradual decrease. Starting September, both of maximum amounts lines and the average sharply grew to 2,806.5 mm and 1,852.91 mm respectively in November. The minimum lines in March was rapidly surged in 866 mm in April and continued gradual increase in 940 46 mm in May. The best parameter used in the maximum likelihood estimation. This table shows that the exponential distribution requires rate parameters, while gamma distribution requires shape and scale rate parameters. Variable distribution requires shape and scale parameters. Meanwhile, the parameters which are the mean and standard deviation in normal distribution can straightforwardly give an intuitive understanding of some aspect distribution, the ability of all distribution, and the estimated parameter to fit the empirical distribution of the value was examined using the Anderson-Darling of goodness of fit. For the goodness of fit test, it shows that Anderson-Darling goodness of fit test indicates that normal and variable models are found to be the most significant model. Normal and variable distribution were chosen based on the greater probability value, which is 0.4364 and 0.25 respectively. It shows that the data follow the specified distribution since the alpha value is greater than 0.05. Next, the best fitting distribution using model selection criterion is shown in the table. It shows that variable distribution has the lowest values, which are 1270.069 and 1275.644. It shows that variable distribution is the best fit distribution among all criteria. It is followed by normal distribution with 1275.344 for AIC and 1280.919 for BIC. Exponential distribution was the highest values of AIC and BIC, which indicates that it is not the best fitting distributions.
As the conclusion, modeling a rainfall distribution based on the rainfall amount is crucial to help us in understanding the precipitation characteristic, especially in Malaysia since it is located in the tropical region. Besides, the government also can take the precaution such as expanding the drainage system in the urban area. It also helps the citizen to deal with large amount of rainfall during the wet season. The government and the citizen can avoid the damage to the property, infrastructure and damage to the crop and plants. Hence, a rainfall analysis is necessary to determine the appropriateness of constructing a water reserve or some other solution for prevention. In the modeling of rainfall distribution, it is crucial to explore well what type of distribution that can characterize the rainfall trend. Based on the result, the most suitable distribution for modeling the rainfall amount was variable and followed by normal distribution. This finding was supported by Norzaida et al. In 2017, which indicate that the distribution of variable was the best distribution for stations located in the inner section of the northern coast of Peninsular Malaysia, while the distribution of gamma was good for simulating rainfall in the outer part of the northern coastal area. Besides, in an analysis carried out by Suhaila and Jmain in 2007, the mixed variable distribution was identified to be the most suitable model for the majority of peninsular locations.
For the future study, we can recommend that to propose a mixed distribution by adding more parameters in the distribution, which can help the researcher understand the new distribution better. Secondly, to collect the dataset with have a perfect value, such as no missing value problems. Next, the future analysis should involve analyzing the result of most recent rainfall data for the purpose of distribution. This can be achieved by splitting the duration of analysis into different smaller periods out to test the distribution match. It is better to get a daily rainfall amounts if it's possible. The researcher also can simulate the data set using the simulation technique to have the cost of applying the expensive data set. Thank you.